So for 11, what do you say? Converge or diverge? What? The terms don't go to 0. What do they go to? Infinity. So you would say something like, because the terms don't go to 0, the series must diverge. You can't add infinitely many things that aren't getting bigger and bigger. Okay? All right. What about the second one? Is it geometric in its totality? No. It is not. But is it geometric if you broke it into two separate series? Is that allowed? It is 2 to the n over 3 to the n, the same as 2/3 to the n if I saw that somewhere in multiple choice. Are those the same? They are. All right. You will see me often write in the bottom of the summation just a 1 there instead of n equal 1. That is pretty typical, but it's fine. So anyway, does this converge? Is this geometric?
Yes.
Yes. What is the common ratio? 1/3. Does that meet the criteria for converging?
Yes.
So because 1/3 is less than 1, it converges, and therefore the sum is A1. What is A1? 2. What is the common ratio again? 1/3. What's 2 over 2/3? 3. Did you get 3 for the first sum? Cool. For the second one, is it geometric? It is. What's the common ratio?
2/3.
Does that meet the condition or the test value of less than 1?
Yes.
It does. So that converges, and therefore it's appropriate to use the formula there. What is A1? 2/3. What is the common ratio? 2/3. What's 2/3 over 1/3? 2. 2. I'm thinking it was 1, but you're right, it's 2. 3 plus 2 is? 5. The sum approaches 5. How did that go? It is subtraction, and therefore it's not 5. It is
1.
1. Thank you. Okay, correct. Thank you. All right. Last but not least, what kind of graph is that? What's the family? It's a limacon. What kind of limacon? Is it? What are the 4 types of limacon? Convex, concave, cardioid, loop. Okay, which one is this? Concave. It's got a concavity to it. It's got symmetry about what axis? Y-axis. So you should, at the 90s, at 0 have a radius of 3. At pi over 2, 5, 3, and 1. It should have a dimple to it, a concavity to it. A pinch is nice. That's so much more pleasant than butt. I like it. Okay. The area. It's fairly common that you'll see multiple choice on the AP test. Which of these integral expressions would or would not find the area appropriately? So let's talk about just what you did. What did you do to calculate the area?
You split it in half and you do 2 times 1.
2 times a half. Okay.
And it's wrong. And negative pi over 2.
The pi over 2 of?
The radius squared.
3 plus 2 sine.
Okay, that will get the correct answer. It's cool. What about 2 times a half pi over 2 to 3 pi over 2?
Yeah.
Does that work?
Yep.
Yes. What about 2 times a half of 0 to pi?
No.
No, there's no symmetry to that. What about 2 times a half of 3 pi over 2 to pi over 2? Not okay. That would be a negative area because you're changing theta in a negative way. All right. Sounds like you understand thoroughly. That's awesome. What did you get for an answer?
34.558. Heck yeah.
All right. You all good? Okay. Today's is pretty cool. It's what you would consider an advanced integration technique. It's integration by parts, part 2 and 3. Circular and tabular. All right. You have already done circular, and so this will be just a quick refresher of the idea. Circular, the idea is to get right back to where you started. Get back to where you started. To the original integral is the goal. Okay, so do you remember how to integrate secant cube? What's something I can do? Secant squared secant. I like it. Okay, good call. Then? So we have two choices at that point. We could either use the identity to sub for secant squared, or we could ultraviolet voodoo. Okay, so now ultraviolet voodoo. U is secant theta, and dV is secant squared x dx, and du is secant theta tangent theta d theta, and v is tangent. Why am I going thetas all of a sudden? These are x's, yeah? My bad. All right, sorry about that. So v is tangent of x. Okay. Keep in mind this is a bit like an identity that you're working the right side. You don't want to lose the left side. You're eventually going to want that integral expression on the left, so we're going to work down with equal, 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 all lining up. You with me? Okay, so uv is? Secant x tangent x is uv, or ultraviolet. Now voodoo. What is the voodoo? Of? Secant, and we have two tangents, so tangent squared. Are we done? Okay, so keeping in mind that we're trying to get back to the original, now's where we use an identity. Okay, so in place of tangent squared, you're putting in the identity. Is it? Did you say secant squared minus 1 or 1 minus secant squared? What is secant squared minus 1? Secant squared minus 1. Your skills are undeniable. All right, so we get something like secant tangent minus an integral of secant cubed, and I'm going to split the integrals and get a positive integral of secant. Do you see where I'm coming from? If I split the secant cubed and the secant into two separate integrals. Are we cool?
Cool.
Now what?
Correct.
That never helps. Now what? Move the secant cubed over. So I'm going to move the secant cubed over to the other side so that now I have two integrals of secant cubed on the left. In the right is secant of x tangent of x, and the antiderivative of secant.
Natural log of
I always struggle to figure out at what point I should put a plus c. I figured I'm going to throw a c in now. And then the final answer then is that integrand divided by 2 or what have you. Are you with me? It might be the same. I'm sorry. C. Okay, are we done? All right. Now, that said, you use that same technique with something like this. Now, this will be circular. Let's get that in our notes. This is going to be circular integration because neither of these, for lack of a better term, goes away as you take derivatives or antiderivatives. Cosine just keeps bumping back and forth between sine and cosine. E never goes away, never changes. So you're never really going to gradually reduce out in power until stuff's gone. Your only hope is to get the same thing back, all right? Now, it's also cool here in that in terms of choosing U for the ultraviolet voodoo, it doesn't matter which you choose, but you must stay consistent. I will explain. You're going to have to ultraviolet voodoo twice, and you must be consistent both times. That'll make more sense in a second. Okay. So, as I just said, it doesn't matter which you choose. So, I personally say it's easier to take derivatives without error than integrate without error. But you guys are such high level, you probably wouldn't screw up either. But I generally choose the U to be the uglier one, and so I would say I'm going to let U equal cosine. In the dv, the integration, I'll choose usually the easier one. So what's du? The derivative of cosine 2x is negative 2 sine of 2x, oui? dx. Differential. What's the antiderivative of v? dv. E to the x. Cool. All right, so then by ultraviolet, I'm talking e to the x cosine of 2x minus voodoo is something like
Negative 2 e to the x sine of 2x.
plus, so minus negative, so it'll eventually be plus 2 e to the x sine of 2x dx. We? Cool. All right. Now, that, I think you'll agree, is a new integral that is not any better than the first. And so, now we're going to ultraviolet voodoo this guy. I'll do it in red here. Now, when I say stay consistent, if you let U be the trig the first time, then you need to let U go trig the second time. You can't now switch gears into being U is E, then you'll be right back to where you started. So, U is sine of 2x, and dv is 2e to the x dx, we? And du is? Two cosine 2x, and v is 2e to the x. All right, so here we go. Being careful not to lose our first part that was outside the integral, e to the x cosine of 2x. Now we're going to add to that our new uv. Our new uv is 2e to the x sine of 2x minus our new voodoo is 2 or 4.
4.
So here's my voodoo right there. So 4 e to the x cosine of 2x. We? All right. Now that is the objective, is to get back to where we started. That is, with the exception of the 4, which is not really a problem, the same as the original integrand, yay? So now I can move that over, and on the left side now I have a total of 5 integrals of e to the x cosine of 2x dx, and it equals what on the right?
E to the x cosine of 2x plus e to the x.
We? And then a C in there. And then the end result then is the original problem, e to the x cosine of 2x dx is all that divided by 5. Pretty straightforward. Are you with me? Okay, cool. Now, when I say go away, that's important to the next skill, tabular. There is a quick way to do repeated integration by parts, and it's called tabular integration. So let's look at this first. Would you do this by integration by parts and give me an answer so we can refer back to it and see how the tabular works? You will have to do integration by parts twice. Is Todd done? Okay, do you agree with x squared e to the x minus 2x e to the x plus 2 e to the x plus... Okay, why did this require two integration by parts?
So x squared requires twice.
Okay, it took 2 to get from x squared, keep going, you're on the right track. X squared down to
To
2x down to 2 to 2. Yeah? All right. Now, rather than do all that work, there's a quick way to do this, and it's called tabular integration by parts. So the first thing you're going to do is make a table that looks something like this. It's tabular for a reason. It's u and its derivatives. And usually you would just title it u, but for your note purposes, title it u and its derivatives. And the other is dv and its antiderivatives. Right? Now, at the top of the table, just like you do in integration by parts, you choose your u and your dv. We let u equal x squared, and dv was e to the x dx, okay? Okay. X squared and e to the x. Now don't worry about the dx, I'm just going to leave that off. But as you take derivatives of x squared, you go to 2x, then 2, then 0. Now keep taking derivatives until you get to 0. Okay? Derivatives until 0. We Antiderivatives of e to the x are e to the x, e to the x, and e to the x. You continue that side until it's even with the other first column. Weeks. All right. Now, I think you'll agree that in our answer, the first part of our answer was the uv. Yeah? Now that actually is, this is the u, but isn't v this?
Yeah.
This would be v. So that's your first product, and it's positive. 2x e to the x came from the second time through, and it was negative. Now that's by virtue of that negative in the integration by parts formula. Minus that second thing is negative. When you get to the third, however, that's negative of a negative, and that's back to positive. So you'll see this diagonal products, alternating sign pattern, and once you run out of stuff to combine, that is your answer. X squared e to the x positive minus 2x e to the x plus 2e to the x. And then c. Obviously, that's the same as the answer we just got below. Are you with me? Questions about anything, where that's coming from? Okay. Try this one then. Expectation is when you integrate cosine into x, you're not actually u subbing. It's a mental u sub process that would take forever if you're going to u sub every time you integrated cosine or sine into x. right? Okay. So u, as long as you chose u as x cubed, then the derivatives are obviously probably fine. dv and its antiderivatives require a little more skill, so check your antiderivatives. Is the cosine 2x antiderivative 1/2 or negative 1/2 sine of 2x? It's positive. We'll be subtracting it. No, that'll be positive, right? It's just positive, right?
Yep.
Okay. What about the antiderivative of 1/2 sine of 2x? That's negative, and we pick up another 2, so it's now negative 1/4 sine of 2x, yeah? Did I make a mistake?
You wrote it.
Oh, it's just, thank you. Thank you. Okay, and so the next antiderivative is? Negative 1/8 sine of 2x, and the last? Positive 1/16 cosine of 2x. Did I make a mistake again? So it's positive, negative, positive, negative. So when it's all said and done, our first answer is 1/2 x cubed sine of 2x. Do you agree with that?
Yes.
Okay. Then we have a negative negative, so it's positive 3/4 x squared cosine of 2x. Do you agree with that?
Yes.
Okay. The next one is positive times a negative, so it's negative 3/4 x sine of 2x, yay? And then the last is negative 6/16 or 3/8 cosine of 2x plus c. And we're done. Are you with me? Okay. Do we need to do the next one, or you get the gist? Got it? Okay. Okay, cool. Questions on, this is last year, I didn't do that. Okay, questions on, so of course I thought I posted them correctly before, but I believe I really did post the answers correctly this time. And so you're going to turn in 119 and 120 today, and last night's homework 121. We?
Oh, yeah.
Yay! 121 questions. What are they? 13? 15. 10, 15, and
Hold on.
hold on. 15, 10, 0. What? Oh, that's a good stretch your question. You could do it.
I have a question about that.
Don't you want to challenge yourself?
Not really.
You got a mind like a Ferrari. You just want to mess around in a parking lot? Why don't you take it on the highway? Let's go. Come on.
No, I like my sticker.
Oh, we're gonna go. Let's find out Luke, baby. All right. Luke question. Sounds delightful. All right. So should we do 5 first? Yay! This is good stuff. Hey, so 5 on 121. Find the area inside the loop, which is not in the back of the book, the loop area problem. It is.
Whack.
Okay, so we have, did you get something like 3, then 1,
Problem number? The problem number was like
we? You with me? Now, it's important that you actually understand how the graph is made here, because otherwise you're going to have a hard time. So you're going from r equal 3 to r equal 1, and then when you get to here, r is negative 1. Now the question is then what happened at these angles in between? Well, r went from positive 1 down to negative, through 0 and to negative 1. So it must have been little less than 1, little less than 1, little less than 1 until it got to 0. And then it was little backing ups from the second quadrant, which put it in the third quadrant. So that's what happened in between. You with me? And then as you go from r equal -1 back to r equal +1, then we're going to be backing up, but a little less, until r is 0 again, and then we're going forward again. Something like that, yay? So when does the loop stop and start? At 0, okay? The loop stop and start is when r equals 0. So if 1 plus 2 cosine theta equals 0, then that's at cosine theta -1/2. Where is cosine -1/2? Theta is that a pi over 3 or pi over 6, and in what quadrants is cosine negative? It's pi over 3, cosine of 1/2 is pi over 3, and it's negative in the second and third. So what's a pi over 3 in the second? 2 pi over 3, and in the third? 4 pi over 3. All right. Now, if you were to do this without symmetry, then you could say 1/2 from 2 pi over 3 to 4 pi over 3 of the square of r. Right? What if you use symmetry?
You go to pi.
2 to 1/2 from where to pi?
2 pi over 3 to pi.
2 pi over 3 to pi. That also would work. Okay? They should yield the same answer. Everybody do that and kill it? Get it? Don't be so shy, brave person. You got it. 0.5? 4? 0.544? Okay? That makes sense to me. Because of the magnitude of the numbers here, you're talking this is 1, and that's much less than a 1 by 1 square or a 1 by 2 rectangle. So it seems like it's in the right ballpark. Okay? Are you with me? Good job. Okay. 15. Question on 15. You got it?
Yeah.
Okay. 10. What the heck? Would we have time to ask questions? You don't have any? All right, 10. Here we go. We're not doing a little tirade there. All right, so 10.
Conspiracy theory against
Yeah. Just trying to tick me off. 4x plus 2.
He said 2, because that's where
X
sine
squared.
equals.
Okay, this does get messy. How many partial fractions?
You just put it on the board, Micaiah. Okay.
I'll integrate in a second, but wouldn't you agree that this is going to be 4 partial fractions?
Yeah.
Okay, so a over x, actually I'll do this in the same order. Did you do a over x, b over x squared, c over x plus 1, and b over x plus 1? Okay. It's arbitrary, but if it's your question, I might as well do it like you set it up. All right. So with that cleared, with the fractions cleared, it's negative x cubed plus 2x squared plus 4x plus 2 is a times, you're multiplying through by x squared, x plus 1 squared. So you'd get an x and an x plus 1 squared. This, you'd get an x plus 1 squared. This, you'd pick up an x squared and an x plus 1 to the first. And d, you'd pick up an x squared. I assume that's just fine. All right, the next two things are probably isn't it c times x squared and x plus 1? You agree? Okay. Okay, now then, as we let, two things will go nicely with let, two things not so nicely. So when we let x equals 0, we get 2 equals gone, and a is gone and b is left, so you get 2 is b and everything else is gone. Yes? Okay, cool. And when you let x equal -1, You got your 1 plus 2 minus 4 plus 2 on the left, so that side seems like 1. Are we cool? And on the right, gone, 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 left with D. So it seems like I'm getting a D of 1. Are we cool there? Alrighty then. Now the harder part is getting the A and the C. Here we go. For the A, I'm going to, so I was going to focus on x cubes. Negative 1x cubed. And on the right, what contributes to x cubed? A and C. Now that's a wee bit problematic because that's two things we don't know. So that sucks. Let's look at x squared. Should we look at x squareds? This has x squareds. You want to look? Would x's be good?
I wish I could help you.
So that's definitely got x's. I'm down, but this does not have x's.
This was the whole.
So good call. I agree.
So you don't need more.
Okay. So let's focus on x's. I agree with that. So on the left-hand side, there are 4 x's. And on the right-hand side, a has a normal x, and it's a times 1, yeah? B has a normal x, and it's 2bx, So there's 2b's. X squared does not have any normal x's. It has x cubes and x squares. And D does not have any normal x's. So that's cool, good call. A plus 2b equals 4. Assuming B is 4, 2, excuse me. Assuming B is 2, then A must be 0, which implies then that C must be. Now go back to your cubes. If A plus C has to be negative 1, then C must be negative 1. You with me? A lot of deduction here. Oh, it's like a big old Sudoku or something. All right, are we ready to integrate this? All right, so because A is 0, I have no over x's. B is 2, so my first factor is 2 over x squared. C over x plus 1 becomes negative 1 over x plus 1. And D over x plus 1 squared is 1 over x plus 1 squared. Are we cool? Okay. Then it's just integrating well, differentiating between power rule and logs. The first one, is it log or power rule? Power rule. So it's negative 2 over x, yeah? And the second one is log. And the third one is back to power rule. What's the third antiderivative? Negative 1 over x plus 1, 2. First, I gotta put this one. Plus. Pretty gross. I gotta say that. Pretty gross. All right, good call. Anything else? 3? Okay.
Yeah, we're 3.
Okay, good stuff. Would you agree that vertical tangents happen when there is rise but no run? So that implies that vertical tangents are, given that dy dx is the slope, and the denominator comes from dx dt, and in parametric I'll find a vertical tangent if dx dt is 0, yeah? A horizontal tangent is when there is no rise and some run. So not 0. So that implies there's a horizontal tangent if dy dt is 0. You done? So with that said, number 3 would have a vertical tangent already. Okay, so vertical tangent. Vertical tangent is if the denominator is 0, that's dx dt is 0. So vertical tangent is never, right? Oops, 1. None. 1 is never 0, yeah? Horizontal tangents. Horizontal tangent is if 3t squared minus 6t is 0. And therefore there are 2 zeros there, so 0, 2.
Yeah.
Now the only question is, do they want times or points? They want points on the curve. All right, so at time equals 0, what is a point of the curve? That's 1.
0 or 3.
3, 0, yay? And when time is 2, what is the point, or what are the coordinates? 5, what we got there?
-4.
5, -4, I agree. Okay. There's a lot to wade through there. Really cool. Anything else on the homework?
Funky.
Bene, bene, molto bene.
Still want to know what that looks like.
Yep. Or 120? Sure. Do-we-do. Yes. Yes. Hey. Good, probably syrup. All right. 120, number 19. Shoot. That was a hard dinger, right, Ty? I wouldn't be asking about it if it wasn't. All right. So, -4 to 4. Do I have the right question? Okay. So, this is rough. I wasn't even sure how I would do the geometry, but I'm going to do it with calculus anyway. All right. So, calculus. I'm going to leave the limits off and figure out the antiderivative by trig subs. It's hard enough to trig sub without getting the limits in. Are you with me? Okay. So, I'm going to say, what is the antiderivative to this function? Let me jump to this. Did you eventually get to something like 25 of an integral of cosine squared? Or do I need to fill in the gap between there? Do you agree with that? You do? Okay. And so I assume you integrated, I'm going to pull out the half, 1 plus cosine of 2 theta. So you got something like 25 halves of theta plus 1/2 sine of 2 theta. Yeah. The plus c is not an issue. The problem is that if you have x equals 5 sine theta, or x over 5 equals sine theta, it doesn't really do you any good with 2 theta. So you need to change that by identity to choose sine theta cosine theta. You know? Okay. So with that said, you get 25 halves theta. Oh no, I can sub that. So what is theta in x terms? Inverse sine of x over 5. I agree. Okay. And sine of theta is x over 5. the cosine of theta is root 25 minus x squared over 5. Do you agree? I don't know if it would pay to distribute that or not, but so that implies that negative 4 to 4 of 25 minus x squared dx is the antiderivative. Did you distribute that or did you leave it out? Okay. So 25 halves inverse sine of x over 5 plus x root 25 minus x squared over 25 from negative 4 to 4. Are we down? Okay. So at 4, I get 25 halves of inverse sine of 4/5 plus 4 okay, let's see, parentheses. 4, when I put 4 in there, it's 25 minus 16, so that's 9 square root, so that's a 3. Pretty cool. Alright, minus 25 halves, and negative 4 goes in, inverse sine of negative 4/5. Oh, I wonder if they used even odd to clean this up. It just occurred to me you could clean this up. Negative 4 times 3. This one is negative 4 times 3 divided by 25. Are we cool? So I think on my paper I just stopped there, but did they combine these?
I don't know. No.
So you could, isn't sine, inverse sine of negative 4/5 the same as the opposite of sine of 4/5? Opposite inverse sine of 4/5 because it's odd.
Yes.
So you could technically make this sine of 4/5 and combine it there. And so you might have something like 25 inverse sine of 4/5. I didn't even think about that. I thought you couldn't combine them, but I think you can. And then what about this stuff? This turns out to be a, what, a 6? A 6 and a negative 6, so that's plus 4. Wow. So I didn't simplify as much as I could have on my homework. Okay, cool. How was super today, people?
Have an interstellar day.
Interstellar day. I don't think I've ever been wished an interstellar day before.
Yes, sir.
Thank you, sir.
Thank you. Have a good one. Be nice person. Yep, and in.
No, I think the problem with how far I got
Oh, no.
I don't know.
No, this is really, that statement, portion of rabbits and root for rabbits, that's the.
Yeah, turning gases of
So
all.
think this, so logistic. This is where you should be headed.
No.
Probably read the whole X. I finished 3 problems on my homework.
Is that on? Oh, nobody asked about that one.
What?
120 number 1. Why?
I see AP physics with unit 7 hours, and I can make up the test.
Oh, that would be great. I will be here after school. That's good. Thank you.
It was like 6 different dances all in one. There we go.
Hello. Okay, so we need to clean this up. Stop there. K is, you might have to find the K from the 2 cases.